Hello, Geometry. Welcome to your second week of exciting, fun e-learning. Yay. So it seems like everyone did pretty good last week with area, probably because that was very familiar. We'd done area before in middle school, probably a little bit in elementary school too. Like that's a pretty familiar topic, maybe with just some additions of adding in like the rhombus and the kites and the trapezoids. Um, so today we're going to move on and talk about three-dimensional figures, right? We had to cover area so that we could talk about three-dimensional figures because we can't find things on three-dimensional figures without understanding two-dimensional figures first. So this week's focus is all going to be about surface area. Surface area would be like, for example, if I decided I wanted to take a box and cover that box in a different paper, like a wrapping paper, exactly so that it changed the box's outside, right? I would find the area of the side of the box, the other side of the box, the front side of the box, the back side of the box, the top of the box, and the bottom of the box. And I would take all 6 of those areas and add them together, and that would be the total surface area. If you think like a soup can, you might want to find the area around the side. We would call that the lateral surface area. Whereas if you also found the area of the top and the bottom, we'd call that the full surface area. So that's kind of the focus of this week, is finding surface area. And then next week we'll move on to volume. So again, this week's going to be a lot of notes. So if you're okay with, formulas. So if you're okay with formulas, that will make this week pretty easy. So let's actually jump over to our notes. Page 31, like I said, we're talking about geometric solids and nets today. This is all going to be vocab here. I don't have any examples or anything in this. It's all vocabulary that you just need to feel comfortable with and be ready to use. So the first thing is that we're going to talk about geometric solids. That's our fancy geometry way of just saying a 3D shape, right? We'd call a two-dimensional shape a polygon. Well, if I want to talk about a three-dimensional shape, we call it a geometric solid, or we could just say just a solid. If I say a solid, you know what I'm talking about. The other important vocab word is a net. A net is if you were to take a three-dimensional shape and unfold all the pieces so it laid flat on the ground. So going back to like talking about that box from earlier, if you took a box and you cut all the sides of the box down, right? And then unfolded the box, and then the top of the box would like unfold and then fold all the way down. You had that big box unfolded into just a flat shape. That would be the net of the box, or the net of the rectangular prism is what we're going to call it in the future. So just think about unfolding a three-dimensional shape. This is really something that those of you who noticed in my class, you know, that chandelier with all the shapes hanging above it, those were nets originally. What I gave my students was a piece of paper, and they cut out this piece of paper and decorated it, and then they folded it and glued all the pieces together. And as you folded it together, it became a three-dimensional solid. So just think about that. If you took a paper and you cut it out and then folded it into something, that's you taking a net and turning it into a three-dimensional solid. Okay, so our first word that we're going to talk about is a prism. Prisms are typically one of the more common seen three-dimensional solids. A prism has 2 bases on either end that are congruent to each other. The top and the bottom are the exact same thing. And I said top or bottom, and I shouldn't have said that. Bases don't always have to be the top or the bottom, right? A base could also be on the side and the side. What is important is that you have 2 polygons that are the same exact congruent shape. The sides around it are all rectangles that connect it, and that makes it a prism, is when the lateral surface, or the side, is a rectangle, and the bases are some sort of polygon. So you can see over on this right-hand side, I have 2 shapes drawn for you. This top one right here, you can see the base here is a triangle. And again, I said base doesn't have to be the bottom. That is super important. Base doesn't necessarily mean bottom like it does in the real world, right? In the real world, we say base of a lamp, or the baseboards in your house, right? We use base to represent bottom. That is not necessarily true in geometry. Base here is just 2 shapes that are equal to each other. So you can see there's a triangle on the front here and a triangle on the back here. Those would be your bases then. And you can see the lateral surface all around the side are all those rectangles that connect it. Okay. Next, you've got this little rectangular shape, the box. We would call that a rectangular prism. By the way, the top one was called a triangular prism. I don't think I said that. Triangular prism. This one down below is a rectangular prism. There is no clear idea where the base is there. The base could be those 2 squares off on the edges. It could also be the 2 rectangles on the top and the bottom. It could be the rectangles on the outsides facing towards you and away from you. In a rectangular prism, any of them can be the base, because The whole point of being a prism is that you're connected by rectangles all around. And since every shape on there is technically a rectangle, it doesn't matter which ones you make the lateral surface. It just works anyway. So remember when you get to rectangular prisms, sometimes it gets confusing because like which one's the base, which one's the height, which one's the... It doesn't matter. You just plug the numbers in and go. Another thing that I didn't put on here, and let's just make a little note off on the side. There is another polygon that exists that has a special name that pops up in IXL a little bit, and I didn't do a great sketch there. That's a really bad sketch. Think about a dice, though, right? A dice is squares all around. It's not rectangles, it's squares. Careful. Careful. That's decent. That's decent. So we would call this a cube. Keep that in mind. Cube is the other one for a square prism. We just call it a cube. It's a special name. Okay, the next one to talk about, it goes with prisms, and I put them together because a cylinder is the same exact thing as a prism. You've got two bases on the end, which in this case happen to be circles, and they're connected by one shape in the side that's called a rectangle. If you have not watched Mr. Nakarato's bonus video, you should watch Mr. Knox's bonus video. It's one of my lessons I love giving in class because it's a true story and it's absolutely ridiculous, and it was the highlight of my internship before I started teaching. It made me really question a lot of my sanity. So watch that video if you haven't yet. But cylinder, two circles, two bases with a rectangle around the outside. My next one is a pyramid, and this is really important to talk about because when I say pyramid, I know most of your minds are like, oh, you mean the pyramids of Giza? Yeah. Well, yes, but that's only one type of pyramid. That's a rectangular pyramid. There is numerous other types of pyramids, right? So a pyramid is just any shape that has a polygon as a base. So if you think about the pyramids in Egypt, there's a rectangle or a square as a base, and then triangles that come up on the sides and connect it. That is just one type. You could also have a triangle on the base. If you had a triangle at the bottom, and then a bunch of triangles connecting up. Again, if you think about my chandelier, I know some of you might not have looked at it very carefully, but a chandelier, that chandelier I had up there with the triangles, there were some on there that were little triangle shapes. You could also look up a four-sided dice from Dungeons & Dragons that I love playing. If you look up a four-sided dice, that would also show you a triangular pyramid. But you can also have hexagonal pyramids and octagonal pyramids, and that would be like 8 sides with 8 triangles all coming up and meeting at a single point. In this problem, again, the base is the part that is not a triangle. The piece on the bottom, which I should say not triangle, is not correct. It's not a triangle so long as it's not a triangular pyramid, right? But it's the part that is the single polygon that's unique. Then the lateral surface is all the triangles added together. You can see my pictures over there. I put a what over there because I tried. That's all I got for you. I tried. I couldn't do it. So hold on, my dog's trying to come in. So with those, I really would suggest that you look up some types of pyramids. Look up some rectangular pyramids, which, like I said, you probably know what those are. But look up a triangular pyramid. Look up a hexagonal pyramid. Look what a picture of them looks like drawn by someone who is a little bit better at art than I am. On top of that, the next shape that kind of goes with it is a cone. And a cone is a circle, one circle, but this time it's connected by what looks like a triangle, but what happens is when you unfold that triangle, and I'll show you on the bottom, it kind of looks like a Pac-Man shape. Think about if you took an ice cream cone and cut down the side and unfolded it. It wouldn't unfold into a triangle. It would unfold into this like strange circular looking shape. And like I said, it looks like a Pac-Man shape. If you know what Pac-Man looks like, it looks like Pac-Man. It's kind of got this like rounded edge with a triangle cut out of it. And that's just one type. You also might see them like really widely opened, kind of like, that's a terrible circle, but like that, you know, that looks the same. Don't look at that. Ignored. Sometimes you might see them look like this. So it's still kind of Pac-Man-y, but it's not as Pac-Man-y. And my last one, my last 3D solid that we have to talk about is a sphere. And I didn't really write much for a sphere. You all know what a sphere is. A sphere is a ball. It's a three-dimensional ball, right? It's the globe. We live on a globe. On the Earth is a sphere. It's just a ball shape. It's a bunch of circles connected together to make a three-dimensional circle. Okay, here I just drew some pictures of your nets so you can see what they are. If I took a hexagonal prism, so you can see there's a base right here, right, and a base right here. There's two bases. And if I folded up all these rectangles along the sides, it would make this lateral surface on the side, and then the other rectangle would close on the top to be like a lid. A cylinder is a rectangle with two little circles on it, one for the top base, one for the bottom base, and like I said, it's a big rectangle around the side. Again, watch my video if you need to see that. The triangular pyramid, I showed an unfolded triangular pyramid. You can see there's a triangle on the bottom that would represent the base, and then I got each triangle on the side that folds up to make it. Same thing like for a rectangular pyramid. You'd have a rectangle for the base and then a bunch of triangles on each side. And you'll notice the number of triangles is always equal to the number of sides of the base. Same thing over here. The number of rectangles is equal to the number of the sides of the base. That will always happen. A cone is like I said, a circle with a little Pac-Man shape. That's a cone, unfolded, it's net. A sphere, I'm not even going to try it, but to give you an idea of what it would look like, it would be something like little pieces like this, over and over and over again, repeating for quite a while, and you'd fold that all together and make like a ball-like shape, but it's kind of weird. So, like I said, just vocab there. As long as you understand that vocab, you're in good shape, and you will be okay for the rest of this chapter. Okay, bye y'all.